Hey there, and welcome. If you've ever had to work with data, chances are you've heard of Matlab. Over the next few minutes, we're going to pull back the curtain and show you what it's all about. We're going to start super simple with just one calculation, and then step by step, we'll build our way up to the most important concept in the entire language. All right, let's get our hands dirty. The very first place you're going to live inside Matlab is the command window. You see that prompt right there, the two little arrows? That's basically Matlab asking, okay, what do you want me to figure out for you? So let's start with some simple math. And the good news is, the basic operators are exactly what you already know. Plus for adding, minus for subtracting, the little star for multiplying, and a forward slash for dividing. Seriously, no surprises here, which makes it really easy to just jump in and get started. Okay, let's type in our first command right at that prompt. Let's try 1 plus 2 star 3. Now before you hit enter, just think for a second about the order of operations. Remember that from school? Well, Matlab knows the rules. It's going to do the multiplication before it does the addition. And there it is, 7. But hang on, look closely. Matlab didn't just spit out the number 7. It said ands equal 7. What's that about? Well, if you don't tell Matlab where to put the result, it automatically stores it in this default variable called ands. It's pretty handy for a quick check, but be careful, it gets overwritten with every single new calculation, so you definitely don't want to rely on it. Let's look at a much better way. To do any kind of real work, you need to save your results so you can use them again later, and this is where variables come into play. Just think of them as little labeled boxes where you can store your numbers for safekeeping. So let's try that last calculation one more time, but now let's actually save the answer. We're going to create a variable. Let's call it x, using a simple assignment. You just type the variable name, an equal sign, and then whatever you want to calculate. And check it out. This time, instead of ands, the output shows x equals 7. We've successfully stored that value. Now, from this point on, anytime we use the letter x in a calculation, Matlab will know that we really mean the number 7. Now, variables aren't set in stone. You can update them all the time. So here, first we'll create a variable called t and set it equal to 5. And notice that semicolon at the end. That's a neat little trick. It tells Matlab, hey, do the math, but don't show me the output. It's great for keeping your screen from getting cluttered. Then, on the next line, we say that the new t is equal to the old t plus 1. And just as we'd expect, the new value of t is 6. This simple idea of updating a variable based on its own previous value is a massive concept in pretty much all of programming. So far, we've only been playing around with single numbers. In the world of Matlab, these are called scalars. But the real power of Matlab is unlocked when you start organizing groups of numbers. The next logical step is a vector, which is just a row of numbers. And from there, we build up to a matrix, a whole grid of numbers. This is the foundation for, well, everything. So let's take that first step up from a single number. A vector is basically a one-dimensional list. Think of it like a single row or a single column in a spreadsheet. This is how we start to handle sets of data instead of just one value at a time. And creating one is super easy. You just start with a square bracket, type out your numbers with spaces between them, and then close it off with another square bracket. Right here, we're making a row vector called v that has 5 different numbers in it. Once we press enter, Matlab shows us exactly what's stored in v. It's not just a single number anymore, it's an ordered list. And just like that, you've created your very first array. And now, we've arrived at the main event. Remember what Matlab stands for? Matrix Laboratory. These things, matrices or two-dimensional arrays, they are the absolute heart and soul of Matlab. Everything we've done so far has been leading us right here. The rules for making a matrix build directly on what we just learned with vectors. We still use the square brackets. We still use spaces to separate numbers in a row. The only new piece to the puzzle is the semicolon. A semicolon tells Matlab, okay, stop this row and start a new one right below it. So let's put it all together. We're going to create a matrix, we'll call it A. We open with a square bracket, 1, 2, 3 makes up our first row, then a semicolon says time for the next row. 4, 5, 6 is our second row, another semicolon, 7, 8, 9 is the last row, and we close it all up with a final square bracket. And there it is, a perfect 3 by 3 grid of numbers. This structure, this right here, is why Matlab is so incredibly powerful. A digital photograph is just a giant matrix of color values. A sound wave can be represented as a matrix of frequencies over time. This is the key that lets scientists and engineers analyze hugely complex systems. So let's just recap for a second. In just a couple of minutes, we've gone from using Matlab as a basic calculator to storing values in variables, to organizing data into lists called vectors, and finally, to building its most fundamental structure, a matrix. You now have the essential building blocks. But as David Hakwak, the author of our source material, really emphasizes, the whole point is learning by doing. Honestly, the best way to make any of this stick is to just get your hands on the keyboard and start trying things yourself. And that's our quick introduction. You've gone from a simple sum to creating the exact kind of data structure that's used to analyze everything from the stock market to medical scans. You've taken that first, most important step. So now the real question is, what are you going to build next?